Good morning, physics fans. How we doing on this fine Wednesday morning? It's not raining outside, and the sun's coming out every once in a while. It's okay. We'll take a little bit of that. I thought it was going to rain all day, and if we're not raining, that's a good thing. We're going to work through another problem here today. Once again, I'll post a review sheet for you for a chapter test on Friday over Chapter 8 in the specific heat and heat of fusion, vaporization, and so on. We're going to go through one problem here. Talks about 20 grams of water at negative 10 degrees Celsius is added to 400 grams of water at 50 degrees Celsius in a Yeti and is closed up. After the ice melts, what is the final temperature of the water? Well, we can increase the speed of the ice melting by continuing to shake things up because what will happen is the water will continue to mix and the warmer water will get closer to the ice cubes and things will melt a little bit quicker. But what we have here is in this Yeti, we have water at 50 degrees Celsius and we have 400 grams of this. And then we drop in these ice cubes and we have the mass of the ice is 20 grams and this is at negative 10 degrees Celsius. And we want to know what's the final temperature going to be. Now, when we're dealing with this, we have to take phases and we have to put the ice through phases because the ice is eventually going to melt. So what we have to do first is we have to take this ice, we have to take the ice from negative 10 degrees Celsius to 0 degrees Celsius. And then we have to melt, which is fusion. We have to take ice at 0 degrees Celsius to water at 0 degrees Celsius. And then we have to take this water, which used to be the ice, from 0 degrees Celsius to a final temperature. And then we have the water at 50 degrees Celsius. We have to go from 50 degrees Celsius to a final temperature. Now there's a lot of heat that's going to go on, a heat exchange that's going to go on to do this. It's going to transfer heat from water into the ice and we go through fusion. There's a lot of heat that gets added into this. So if we add all these up, all these heats up, we should add up to equal the value of 0. And that's by law of heat exchange. Well, how do I deal with taking the temperature and raising the temperature? Well, we have MC delta T. We have our heat of fusion times our mass here. We're going to have MC delta T here and an MC delta T here. Because we're taking the substance and we're just increasing the temperature of the substance. Well, if we take a look at the ice, we need to once again make sure we are in kilograms. So this is 0.02 kilograms. 400 grams is 0.4 kilograms. So the mass of the ice is 0.02. 0.02. The C for the ice is 2060. And my delta T is final minus initial. Well, my final temperature is 0. My initial temperature is negative 10 degrees. So I have 0 minus a negative 10. Then we go through fusion here, which is our mass times our heat of fusion. So our mass is once again 0.02, and we have 3.34 times 10 to the 5th. We add to this, now the water, the 20 grams of water that we're putting in here has to go from 0 to a final temperature. So we have 0.02. Now, this is changed to water. So if this is changed to water, we have to use the heat of fusion for the water. So we have the 4180, and we have T final minus 0. Once again, T final minus T initial. The ice is starting out at 0, that's melted to water, is starting out at 0, and then going to a final temperature. And then we have the water that originally was in here goes from 50 down to a final temperature. So we have 0.4, 4180, and T final minus the value of 50. And when we add these up, they should add up to equal a value of 0. Now, once again, we have to watch ourselves. So we have 0 minus 10. This is a value of 10. So we could start clickety-clacking through the calculator. We have 0.02 times 2060 times 10. We get a value of 824 joules here. Here we have 0.02 times 3.34 e to the 5th. We have plus 6680. 0.02 times 4180. We get 8.36 or 83.6, but that's going to get distributed over to both of these terms. So we have T final minus 0, and then we have 0.4 times 4180. That gives me 1672. 672 T final minus times 50, because once again it got to distribute. 83,600 is equal to 0. Once again, got to make sure we distribute this over both of the terms. So now it becomes an equation to be able to solve. I can combine these three values here. So we have, let's see, we have minus 76096, and then I can combine my T final like terms here, 83.6 plus 1672. So we have 1755.6 T final, and this is equal to the value of 0 still. Adding this to the other side and dividing by my 1755.6, T final is going to equal to 76096 divided by 1755.6. So we have 76096 divided by 1755.6. And we get a temperature of 43.3 degrees Celsius. This would be our final temperature. So adding 20 grams of water or ice into this water at 50 degrees Celsius, I decrease the temperature by about 7 degrees Celsius. Just an additional type of problem that you'll probably see eventually on on tests on Friday, when you take ice cubes and try to melt them, you'll have to work yourself through that problem. If you have any other questions, feel free to ask. Once again, yesterday I posted a homework sheet for you to have some homework problems for Chapter 8. Additionally, once again, I will get a review sheet to you. I will get that posted by tomorrow morning with solutions on the review sheet. So hopefully that'll prepare yourself for the chapter test on Friday with respect to Chapter 8 and heat, specific heat. Other than that, if you have any questions, feel free to ask. Sorry I flubbed up earlier in the week and had the wrong heat diffusion there. Sorry about that. Make mistakes, can't be perfect all the time. Sorry about that. I miss you guys. Hopefully things are going well for you guys at your house. Hopefully everybody's staying away from any type of illness, and we'll all get through this together, keeping our social distancing. We are close to being done. After the test on Friday, we will have one more chapter. We'll go over some thermodynamics. We'll go over. We'll just skim over thermodynamics, and that'll be the last of the material that we will cover in the class. Other than that, I have nothing else for you. Continue to keep up with the work. You guys have been doing a very good job at doing that. Continue to do that. Other than that, I have nothing else for you. Adios, you folks have a great day.